Good morning, boys and girls, and welcome to At Home with APS. We're so glad you're here today, and we're ready to take a look at our calendar. Second day of a new month. Do you remember what month it is? It's July, and yesterday was July 1st. So today, then, is July 2nd. All right, just getting this month going. And I said that we were going to work a new pattern for a new month in the calendar. So yesterday we had a red circle, and today we are going to have a green triangle. And in just a couple of days, we'll know exactly what our pattern is, and we'll keep it up for the rest of our time together. So today, then, is Thursday, July 2nd. So if today is Thursday, then what was yesterday? What was the day of the week yesterday? If today is Thursday, then yesterday was Wednesday. That's the day when we feel like we're kind of halfway through the work week or the school week. And yesterday was Wednesday, today is Thursday. What's tomorrow? That's right, tomorrow is Friday, and that's a happy day for lots of us because it means we're getting ready to start the weekend, and maybe we have some fun things that we can do on those days off with our parents or our helpers at home. So let's go ahead and fill in our 10 frame for our days of the month so far. We're only going to have how many dots? That's right, just 2 so far. Yesterday was our first day of the month, so we had 1 dot. Today is our second day of the month, so we'll have 2 dots. And what are some ways we can think about our 2 dots on the frame? How many more do we need on this 10 frame to get 10? Can you tell? 5 down here and 3 more here. So what's 5 and 3? 8. 8 more to fill our 10 frame. What if we wanted just to fill 5? How many more dots would we need? Can you see them? That's right, we would need 3 more dots. 2 and 3 makes 5. So those are some other ways we can think about our number of the day. Now, let's go ahead and add to our today's number chart. So 2 is a 1-digit number, right? Because it's only made up of ones. 1, 2. No 10s there yet, right? Not until we add 8 more, like we saw on our frame. Then we'd have 10. So what are some other ways we can represent the number 2? Let's go ahead and write it in words because there's a few ways to write the word that sounds like 2. And when you're writing it as a number, you spell it T-W-O. That is the number word for 2. It's spelled a little differently than some of our other 2s. How else could we represent 2 on our today's number? We've been talking a lot about dot patterns, right? So if we saw 2 on a domino or a die, it would look like this, wouldn't it? That's our pattern for 2. Oh, stop messing with those dots. All right, so that's one way we could represent 2. Oh, what's another way? Could we represent it with addition? Let's take a look at our doubles frame for 2. How could we show this as an addition problem that would equal 2? You're right, it would be 1 plus 1, and that gives us 2. So that's another way that we can represent 2. What if we looked at a 5 frame and we thought about subtraction? Here's 2 on the 5 frame. How could we connect this to a subtraction equation? We know there's 5 squares, right? 2 are filled in. How many are empty? 3. So 5 minus 3 leaves 2. So we could show it with subtraction. 5 minus 3 equals 2. And we know that's true because we looked at our frame and because we know that 2 and 3 put together makes 5. What if could we come up with a subtraction for 2 and 10? Remember we talked about this here. When we have 2 on the 10 frame, how many more do we need to get 10? 5 and 3, that's 8, right? So how could we represent this 2 on our frame with subtraction? We could say 10 take away or minus 8 leaves us with 2. That's another way. All right. Let's go ahead and think about now 2 on our hundreds chart. So we're going to write 2 here. And we have our hundreds chart to help us. Can we jump back 10 to fill in the square above 2? Not on this hundreds chart, can we? So we're going to leave this blank. But let's think about what comes right after 2. What's the very next number? It's 3. That's right. And what number comes right before 2 when we're counting? What's the number you say right before? That's right. It's 1. So we have 1, 2, 3. We can make a big jump of 10 down to the next row, can't we? What's 10 more than 2? It's 12. So below the 2 for our hundreds chart model is a 12. Let's go ahead and count a bit on our hundreds chart. Let's count by 2s. When we count by 2s on the hundreds chart, it's like counting every other number. Let's go ahead and try. Ready? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36, 38, 40, 42, 44, 46, 48, 50. Let's try counting backward by 2s now from 50. Are you ready? Look at my hundreds chart for help or look at your hundreds chart at home. 50, 48, 46, 44, 42, 40, 38, 36, 34, 32, 30, 28, 26, 24, 22, what's next? 20, 18, 16, 14, 12, 10, 8, 6, 4, back at 2. Nice job, guys. Very good. All right, so we're going to get out our counting jar next. Today we have a collection of coins to count. Are you ready? Watch me taking them out in case you can't see them on the table so you can count along with me, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. How many coins in all, kiddos? 15 coins in all. Is that more or less than yesterday? Do you remember how many we had yesterday? We had 13 yesterday. So 15 is more, right? We've been talking a lot about more and less. Let's figure out how many more 15 is. We can count back, right, to figure it out. 15, 14, 13. 15 is 2 more than 13, which was yesterday's number. So if you are a kindergartner, you are going to create a collection. Oh, let's do it this way. You are going to create a collection of 15 items. If you are a first grader, you're going to double that. How many would that be? 15 and 15. That's like 10 plus 10 plus 5 plus 5. So 20 plus 10, it's 30. And if you're a second grader, you're going to double the 30 and make a collection that's twice as big as that. That would be 60. Something else you can think about if you're counting collections and if you decide to count coins, sometimes instead of just counting the number of coins you have, you can also count the value of the coins. And if we did that today with our coins, we have 5 pennies, 5 nickels, and 5 dimes. So let's go ahead and count those together. Dimes are worth 10 cents, right? So 10, 20, 30, 40, 50. 50 cents worth of dimes. Now we'll switch to 5s to add on our nickels, right? Nickels are worth 5, so we have 50, 55, 60, 65, 70, 75 cents so far. And then if we add on our 5 pennies, we have 75, 76, 77, 78, 79, 80. So in our 15 coin collection, it's worth 80 cents if we count up the value. It's another way to think about counting collections. Let's take a look at our riddle for Math for All Seasons. This riddle is called Madam Butterfly. My life has taken quite a turn. I used to be a lowly worm. Now I spread my wings and fly. Look how cool a bug am I. How many dots adorn these wings? See what clever thinking brings. There is a mate for every one. Make groups of 10 and you'll be done. So let's look at the dots on our butterflies. We need to think about making groups of 10. So let's see. This butterfly has 1, 2, 3, 4, 5, 6, 7, 8. What goes with 8 to make 10? It's our number of the day, isn't it? Do you see a butterfly that has 2, our number of the day? There it is. So these 2 go together to make 10. Let's see if we can match up the other ones and make a 10. Here we see 4 dots, right? What goes with 4 to make 10? 6. Do we have 6 here? Oh, we do. I see 3 and 3. So 4 and 6 make 10. So we have 8 plus 2, 10. 4 plus 6, 10. 10 plus 10, 20. 20 dots in all, and that was pretty easy when we went ahead and made groups of 10. All right, boys and girls, we are going to turn it over to Mrs. Obenshane, who's going to have a task for you, and I think it might be about parties. I'm going to do it with the read aloud.
Alrighty. Okay, we are going to do a problem about parties, like Miss Carnes said. So we are going to talk about a problem of the month called Party Time. And the party that we are thinking about is a girl named Cindy's party. She has invited 2 guests. Each of her guests invited 4 guests. And then those guests all invited 3 more guests. So we have to figure out how many people were at Cindy's party. So we could probably think about this lots of different ways. But the first idea that came to my mind was just to kind of use numbers and maybe some number sentences to try to figure out how many guests were at her party. So we have Cindy, and she invited 2 guests, right? So if this was one of Cindy's guests, and this is the others of her guests, and then each of her guests, this person, invited 4 more. So if I add 4 to the guests who invited them, that should give me that amount of guests. But then these 4 people all invited 3 more people each. So then that means I need 4 3s, right? So 1, 2, 3, 4, and then I need it for the other guest. Now we've got to figure out how to put these together. So we have a 1 and a 4. We've worked on that combination a lot over the last couple of weeks, right? What is 1 plus 4? If we have 1 and 4, that makes 5. So we could put these 2 together to make a 5. And then we have 3 and 3. How much is 3 and 3? That's another combination we've been working on, isn't it? It's a double. 3 plus 3 is 6. And we have another 3 plus 3 is 6. And I actually see another double that we've been working on. Do you see it? We've done 6 plus 6, haven't we? So the 6 plus 6 is 12. And then I've got 5 more to add on. So I have 12, 13, 14, 15, 16, 17. So each of the first guests that she invited, we ended up with 17. So then we've got another double, kind of like you guys have been doing in counting jar, right? 7 and 7 would be 14. And then I have a 10 and another 10. So the 10 from here, 20, 30, and then 4. But I think I'm missing somebody. Is it 34 people at her party, do you think? Who am I missing? I didn't include Cindy, did I? So we need to add Cindy on. So I think that there are 35 people at her party. But I think that we need to check it. We can use another strategy to check it. Something else I thought about was that we could use a number line and maybe just kind of add the people as we go. So I might have to write smaller. If we start at 1 this time, because that's Cindy, and then we know Cindy invited 2 people, so I'm going to add the 2 people that Cindy invited, and 1 and 2 would bring us to 3 on our number line. And then it says that her guests each invited 4 guests, or 4 more people. So we need to add 4 for one of the guests and 4 for the other guest. And 3 plus 4, so 3, 4, 5, 6, 7. And then 7 and another 4. And I could use a make 10 strategy, was to add the 7 and 4, because I know 7 and 3 is 10, and then 1 more would be 11. So that would get me to 11 people. And then what do we have to do? Those guests each invited 3 guests. So we had all these 3s that we have to add. I wonder if I could do that maybe a little quicker by adding a 6 for 2 guests. Then I'll fit on my number line a little bit better. Well, and a 6 and a 6, maybe I should just add the whole 12. So another guest would have added the 12. So 11 and 12. There's 2 10s there, so that's 20. And a 2 and a 1 is a 3. And then another 12 for this other set of guests. 2. So this 20 and this 10 is 30, and a 2 and a 3 is 5, because that's one of our combinations we've been working on. So 35. And that's what we got when we added Cindy on, right? Here was our answer when we used number sentences. Here's our answer when we showed it on a number line. One other way that we could represent this, if we we wanted to actually see the people, I was thinking, is if we have Cindy, and she invited how many people? Right, 2. So Cindy invited a person here and another person there. And then each of these people invited how many people? They all invited 4, right? So these people are all here. So here we have 1, and then we have 2. So here's 1, and then we have 2 more people. So that's going to give us 3. I'm going to just keep a running total with these guys. And then 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 more people, and 3 and 8 is 11. And then each of these people invited how many people? They each invited 3, right? Oh, my chart is going to get pretty crazy, isn't it? 1, 2, 3. 1, 2, 3. 1, 2, 3. We can see them all, though, if we do this, right? And then we really could count by ones. So a person here, 3 more on each of these. How many people is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 more people. And we already had 11. So the 10 with 24 is 34, and 1 more would be 35. And we could double check it by counting. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35. So we were right. We got the answer 3 different ways, and we got the same answer. All right. They have an idea on this problem just to take it a little bit further. We'll see how far along we get on this one. That this one was interesting. What if it was a costume party and everybody was wearing costumes? At least it's not 35 people like we saw here. So I've put these people's names on a sticky note. And so we have Mia, and we have Jake, and we have Carol, and we have Barbara. I just put Barb on my sticky note for short. Ford, and Jeff are the people at our party now. Maybe everybody else left and went home, and these guys were the only ones who wanted to do costumes. This is like a logic puzzle, where that one we could use number sentences for. This is kind of a different kind of puzzle. You're going to try to figure it out by making sense of clues. It's almost like a riddle. So we have to figure out what costume each person is wearing and when they arrived at the party. So we know that there are 6 people, and who was first, second, third, fourth, fifth, and 6th at the party. We have to know when they arrived at the party. That's what we're supposed to figure out. And then what costume they had. So let's look at these clues. The person that arrived 4th was wearing a bathing suit. Barbara was the last to arrive. Well, that helps us, right? We know we can move Barbara over here under the 6th because she's going to be the last person. Jake and Mia arrived and stayed together. The first person was dressed as a Ninja Turtle. That's a good clue. So I'm going to put Ninja Turtle over here. That was the first person. Superman arrived before Barbara. Well, we know Barbara was 6th, right? She was last. And Superman arrived before her, so Superman must have been 5th. The Potato Heads were always together at the party. There was another clue about somebody who stayed together. Do you remember what it was? Jake and Mia arrived and stayed together. We'll have to remember that. Ford was a surfer dude. The Ninja Turtle was not Carol. And a vampire arrived after Superman. So we know when Superman arrived. I made sticky notes for our other costumes also. So the vampire arrived after Superman. We had Superman in 5th place, right? In arriving 5th, because that's what this clue said. Superman arrived before Barbara, and we know Barbara was last to arrive. So we were thinking what? That Barbara was wearing a vampire costume, is what that looks like. This clue I'm wondering about. The person that arrived 4th was wearing a bathing suit. Who would be wearing a bathing suit for their costume? Not the Ninja Turtle, not Superman, not the vampire, but it says Ford was a surfer dude. So probably the surfer dude was wearing a bathing suit, right? If you were going to go surfing at the beach. So the surfer dude arrived 4th. So I'm going to put him there. And we know Ford was a surfer dude, so maybe Ford arrived 4th. Jake and Mia arrived together and stayed together, and the Potato Heads were always together. We only have 2 spots left. Do you think I could put the Potato Heads there? Because they stayed together. And who were the people? Jake and Mia. And I don't know if they're really 2nd and 3rd if they came together. So that leaves us with Jeff and Carol. And it says that the Ninja Turtle was not Carol. So she cannot have been first because the Ninja Turtle was first. So Carol must be Superman and Jeff must be the Ninja Turtle. So that's what I'm thinking, was that Jeff was the Ninja Turtle and came first. Mia and Jake were Potato Heads and came 2nd or 3rd. They came the same time. I don't know who came in the door first. 4th was Ford, who was a surfer. 5th was Carol, who was Superman. And 6th was Barbara, who was the vampire. If you have a different way to think about this problem, we have this problem on our website. There are even more extensions. If you wanted to work with like maybe brothers or sisters or some other member of your family to try to figure out some of the other ones, you could either work on another way to figure out if I'm right or not about Carol's party, and if you can think of a different way, or double check me to see if I was right about who came to the party and what they were wearing. I think it's time now for Miss Carnis's book that she's going to read us.
continuing story from yesterday. So I'm excited to finish it. All right. We are also going to look at some vocabulary as we think about our story. Hopefully it will stay. Our vocabulary is getting pretty heavy. There's many words on there. We're going to review them in a bit. Okay. So, before we start, if you tuned in yesterday, you may remember that after we finish today's story, which is called Grandfather Tang's story, we are going to use a special puzzle called a tangram to make some of the characters from the story. And if you didn't get a chance to after yesterday's session, you might want to pause me and go to our resources on aps.edu, and we have there for you a tangram that you can print out and cut apart, or there's also directions for how you can fold up a square-shaped paper and draw a tangram puzzle pretty well and then cut it out. We also are going to be using a worksheet that has pictures of animals from the story to help us to build them. So if you want to take a minute to get those together, you could print them out, or you could just be looking at them on your screen, whatever kind of screen you have on a phone or a computer. Okay, boys and girls. So before we begin, also, I want to add a couple of vocabulary words to our chart. So one word we've been using quite a lot is pattern. We've been adding a pattern to our calendar. And when you have a pattern, it means you put something in a certain order, and then you repeat that order over and over again. It could be a shape, like we've been doing on our calendar. It could be numbers that you're using in a pattern. It could even be sounds. Something else we've been talking about quite a bit with calendar and counting jar is less and more, right? And we've been talking about how many in the jar, and then is it less or more than yesterday? So if it's less, we can count back to figure it out, right? Like today we had 15 coins in the counting jar. Yesterday there was less, so we counted back to 13, 15, 14, 13. We found out that 13 was 2 less than 15. And if there's more, then we count forward, right? For example, one day this week we had 16 things, and that's more than 15. So we would count forward. 15, 16. 16 is one more than 15. I wanted to make sure that we get these on our chart. I'll just put this here for now. And we may add another word after we work on our story. So, here we go. So I just want to kind of recall the story in case some of us watching were not together yesterday. So this story is Grandfather Tang's story. It's by Ann Tompert, and it's illustrated by Robert Andrew Parker. It's a special story, one, because it's based on a Chinese folk tale, and two, because the special puzzle called a tangram is used to help to tell the story. So let's just kind of recap what happened yesterday. The whole story starts with the fox fairies, right? The fox fairies are friends, and they're kind of magical tricksters. And so in Grandfather Tang's story, the fox fairies are playing one of their favorite games, which is to change shapes and try to catch each other. So all through the story, the fox fairies are changing into shapes of different animals. We saw the fox fairies turn into a rabbit, a dog, which ended up chasing the rabbit, a squirrel, which was able to run up a tree and get away from the dog, a hawk, which tried to fly down and capture the squirrel, a turtle, who tried to squeeze inside his shell and hide in the river to save himself from the hawk. Oops, went too fast on that one. A crocodile who got into the river to try to catch the turtle. A goldfish who was able to swim away from the crocodile. And finally, the last thing we saw was one of the fox fairies turned into a goose and was flying away. And that's where we stopped the story. So let's pick it up from there. The fox fairies' names, the friends, are Wu Ling and Chow. And when we left Wu Ling and Chow yesterday, Chow was in the shape of a crocodile, and he was feeling sad because Wu Ling was a goose and he was flying away. Chow said, "Why, oh why did we play that stupid game? I'll never see Wu Ling again." He closed his eyes and sank toward the river's bottom. But just as he touched it, he had an idea. Remember? Did you think about what his idea was? What do you think he'll change into? He popped up again, a goose himself. That's how he could catch up to Wu Ling. He turned himself into a goose. Moments later, Chow was flying after Wu Ling and the other geese. He could hardly see or hear them at first, but he did not let this discourage him. Calling upon every last bit of his strength, he flew forward. Each flap of his wings brought him closer. The wedge of geese slowly grew bigger. He's catching up to them. The honking grew louder. At last, Chow found himself flying beside Wu Ling. "I'm tired of our silly game," he cried. "Come back with me to our willow tree." But before Wu Ling could answer, something stung Chow's right wing. He fell to the ground. Oh no, what could have happened? What do you think? A hunter had shot him. Wu Ling flew down beside Chow, placed his left wing under Chow's smashed right wing, and together they fluttered down to the edge of the forest. The hunter ran toward them. "Fly away," Chow urged Wu Ling. "Save yourself. Fly." "I won't desert you," said Wu Ling. And with a mighty roar, he changed into, what roars? What could he have changed into? A lion. I wonder why he did that. The hunter raised his bow. Wu Ling sprang toward him and knocked the bow from his hand. The hunter ran away, leaving his bow behind. Wu Ling and Chow returned to their fox shapes, and Wu Ling helped Chow to his den, where he took care of him until he was mended. "Did they ever play that game again?" asked little Sue. "Many times," said Grandfather, "but they were very, very careful." "That was a good story," said little Sue. "Let's do another." Grandfather Tang arranged his 7 tangram pieces. "Is this story going to be about a man?" asked little Sue. "Yes," said her grandfather. "He's old and he's tired. He wants to sit under a tree and rest a while." "Is he a grandfather like you?" asked little Sue. "Yes," said her grandfather, "just like me." So Sue arranged her 7 pieces of her tangram beside her grandfather's. "Is that a little girl?" he asked. "Yes," said little Sue, "just like me. She'll sit and rest beside the man." "That will make him very happy," said Grandfather Tang. "And now, little Sue, what will we do?" "We'll sit and rest together until Mother calls us for supper," said little Sue. "That will make me very happy," said her grandfather. Okay, so now it's time for us to try to make some of the characters from our story. If you have your tangram, pull it out. And if you have your sheet that shows the figures of characters from the story, get that out too, because it will help you to make those characters. I'm going to have mine out to help me. Okay. So here's the tangram. When we start, it's always in a square, right? And then we move the shapes around. There are 7 shapes. We have triangles, right? Big ones, small ones, mediums, and then 2 quadrilaterals, a square and a special one called a parallelogram. I want to make a fox fairy since they are the main characters of the story, and that's how this all started. So to make a fox fairy, you start with 2 of your small triangles. I'm going to keep mine kind of sorted at the bottom to help me. And these will be the fox fairy's ears. The fox fairy's face, can you see it on your sheet, is made of a square. There. Got the whole thing? Ah, thank you. We want to be able to see what we're doing, don't we? Okay, so we have the fox fairy's face. Next, we're going to use one of our big triangles and turn it this way so that one of the smaller sides is going straight across the top. This is part of the fox fairy's back. And our other large triangle is going to make for us kind of his front leg, like he's running. We'll use a small triangle on the back for his back leg. And finally, our special quadrilateral, the parallelogram, is his tail. So there is a fox fairy. Which animal did you make? Shall we try another? Go ahead and choose one that you'd like to make from your page, or you can watch along with me as I make another one. I think that I will make now a lion because the story started with the fox fairies, and to resolve or end the story and solve the problem, we had the lion. So I want to make the lion next. The lion's face is made of a square, and we put it on our page so it's kind of like a diamond. This is sort of his face and snout, right? Then we take one of our big triangles, and again, we're gonna put the shorter side up to the top and connect it to our lion's face. This is part of his mane, isn't it? We use another large triangle, and we're going to match it up to our first one to continue with the lion's back. This time we have our longest side sort of facing diagonally. Okay, we're going to take a medium-sized triangle now and connect it onto the back for the lion's hindquarters. He needs some feet, doesn't he? One small triangle will make a foot right here for our lion, and the other will make a foot here. And finally, we have our quadrilateral, that's a parallelogram, makes the lion's tail. And the lion saved the goose. And Wu Ling and Chow lived to play their game another day, and I sure hope they were careful. Play with your tangrams at home. They're fun, and you can make these characters. You can make lots of other shapes too, any kind that you choose. We can also think about the size of things with our tangrams and see what fits inside. For example, we take our big triangle, and I'm wondering, can we fit in our big triangle 2 smaller triangles? These are some things that you can fool around with, or maybe a medium triangle and some smaller ones. There's lots of things that we can try. And when we're thinking about the size of things and the shape they are, the space they take up, we are thinking about this word, area. And I'm going to add that to our vocabulary. We're going to go ahead and bring Mrs. Obenchain back to work with us some more.
All right, so we're going to play our vocabulary game. We played this last week.
This is so fun.
And how this goes, we have all those vocabulary words that we've been working on, and Ms. Carnes added some today. She added less and more, and pattern, and area. And we have circle, triangle from all of our stories. We have coins. We did coins today in the counting jar. So we're going to try to just review some of those vocabulary words. The words we're going to work with are smallest, which we have shown by the smallest amount of cubes, versus largest when there's more. Tens we've been showing with full 10 frames or bundles, and ones with single dots. And you can see that which digit in a number shows that. Quarters were the biggest coin that was worth 25 cents. Dimes were the smallest coin, worth 10. Pennies were worth 1 and nickels 5. A digit is each number inside of another number. Doubling, we've been talking about making something twice as big. Using less than or greater than or smaller and more. Add-ins are the numbers we add together in a number sentence. We've talked about addition and subtraction and using plus and minus with that. Estimating or making a good guess. Measuring to try to figure out the size of something. And you can use an inch to measure. That's a standard unit. And I think you guys also practiced using a thumb. Less and more we talked about. Patterns. Quadrilateral, you used that word today. And triangle and square today a lot. And you had a circle on your calendar. So we're going to play a game called Headbands, where we have our headbands on. We're going to put up a word, and in as much time as we can guess these words in the amount of time from our timer. We get to keep that many cards, and then at the end, when we run out of time, whoever has the most cards is the winner. Are you ready?
I'm ready.
Okay.
Should I go first?
Sure. Why don't you go first?
Okay. Is my word right side up?
Yes, it is.
All right.
Okay. So your word is, can you see her word? It is when you make a really good guess about the amount of something.
Oh, but it's not exact, right?
It's not exact.
Oh, and it starts with an E.
It does.
Estimate.
Aha, I knew you were going to know that one.
Nice.
All right, keep going. You've got more time.
Okay.
Ooh.
Is it a tricky one?
I use sometimes the word number sentence instead of this word. But this is the more like formal math word for.
It's a big long word, isn't it?
It is.
I think, and I remember this one because it sounds kind of like equal. It starts with equation.
Yes. Both of your words have started with E. That's funny.
Wow.
Oh, you might be able to get one more in. Well,
okay.
Hurry. No, maybe not.
Well, okay. Mrs.
All right.
Obenchain's turn.
Okay. All right. Is my word right side up?
Nope. It's upside down.
This is the one that.
Okay.
Can you see my word?
All right. So your word is actually 2 words, and it means when something is smaller or it's worth less than something else. And sometimes we can count back to think about that.
No, you said it's 2 words.
It's 2 words. And it's when something is smaller or worth less than another. It has that symbol that we use that looks like
Less than?
it's less
You
than.
used the word, though. That's what got me confused.
Whoops. You're not supposed to use the word. That's part of the rules. Okay.
Can you see my word?
This is when we put two numbers together and we get a number that's bigger when we put them together.
Addition?
It's addition.
Addition, because when you put things together, they get bigger. That was the clue for me. Oh, I think I'm pretty much out of time, too.
Okay.
All right, are you ready?
I'm ready. Okay. You see my word?
Okay. Yes, I see your word. All right, this is a coin. It's silver.
So it's not a penny.
Nope. Yep, it's not. It's worth a little more than a penny.
Then it must be a nickel because a nickel is worth 5. Is that right?
That is right.
Okay. Oh, still me.
Oh, how funny. This is also a coin, and it's not silver.
A penny.
It's the only one of our coins, right? Remember when you were looking at these coins? It's that copper color, right?
Oh,
think you can
still
go.
me. I keep
Yeah.
forgetting. Okay.
Oh, we've got these all in a row. This is also a coin. It's the biggest value coin that we've been talking about.
Oh, the one we want. A quarter.
A quarter, yeah. Wow, she's getting right through these. Oh, okay, so these are part of a number, and it is, if you're looking at a number, it'll be the number on the right side, or it shows you the smallest amount.
Oh.
It'd be the digit on the right side.
Oh, is it the ones?
It is the ones.
Okay. I think I'm out of time.
Yep, you are.
But you have some time to do a few more terms.
Okay. Okay. Oh, okay.
Okay.
See my word?
So this is also part of a number, a 2-digit number, and it is the part of the number, the digit, that is on the left.
Oh, so a 2-digit number, you said.
It's part of a 2-digit number.
2-digit number, and it's on the left. So it would be your tens number.
It's the 10s,
Oh,
that's
how
right.
funny that I would get that right after you had ones. Okay.
Oh, this one is a shape, and it's a shape with, oh, I hope I remember.
I hope I can remember how many sides
It has,
these shapes
yes,
have.
I was right. It has 6 sides.
Oh, let's see. I think a square has 4 sides. A pentagon has 5. So a hexagon has 6 sides?
You got it. Good
All
job.
right.
That was tough.
One more, maybe.
Another shape. This is a shape that has just 3 sides.
Oh, that one's easy. A triangle.
We use lots of those with our tangrams.
Okay. And I think I'm about out of time.
All right. So I guess we can try another term. Here we go. Let's see.
This is the opposite of largest.
Must be smallest.
You got it.
Okay.
Okay, and this is, so you gave me one where you were telling me that it got to bigger when you put them together, and this is when you're taking some away, the number's getting smaller.
Subtraction.
Yep, you got it.
All
And I think we're
right.
about out of time, so we'll have to wrap that up. I think you might have won that round of that, because you had one where you got like 4 numbers, so that was great. All right, so remember that today was the month of July. It's the second day in the month of July. In your counting jar, you might make a collection of 15 items. You might make a collection of 30, or you might make a collection of 60. You can print out some tangrams and practice making some shapes. You could also look again at our party time story problems and see if you can figure out a different way to work out those problems and see if I was right or not, because you can always come back and check and see what I came up with as an answer. Double check me. What else did we do today? What am I forgetting?
Well, we did calendar. We talked about number of the day. Oh, we did your logic puzzle.
Oh, yeah, that's what we were talking about. All right, well, I think that's about everything for today, and we thank you for joining us, and we'll see you next time. Thank you for joining us at Home with APS.